Hi, everyone. I'm Sage, and I'm the product manager for Wiki Education Foundation's platform for helping people get started on Wikipedia and helping professors uh, run assignments where their students edit Wikipedia. So I've done a kind of general overview of what the project is about purpose-wise before, and you can, if you're interested in that, you can check out the previous session that we recorded on that, or just ask around, ask me. But I'm going to focus here on kind of an overview of the technology that we're using and the basically a kind of tour of the code of this app. So without really much further ado, I'm going to switch to screen sharing and start walking through some of what we've got going on. If anyone has any questions or wants to interrupt at any time, please do. Here we go. So the main part of the dashboard, the sort of center of the user experience, and the sort of like gravitas of the code is around the course pages. So each course has a course page, and these course pages are done completely in React. And so if you're not familiar with React, it's a JavaScript system for basically determining which bits of a page to re-render whenever state changes. And so it manages sort of a like state that cascades throughout all of the different components in it, and then only re-renders the parts that it needs to. And it also has sort of a special syntax called JSX that you can use to basically combine the JavaScript that controls the logic of what a component does with the markup, the HTML that component consists of. And so the way that the course pages work is that when you hit any of the course page URLs, it'll start off and load one of the well, it'll load like the React component and mount that React component on just a tiny bit of HTML that specifies that this is a React route. So Rails will send back a little bit of HTML with some very basic information that React needs to get started, and then the React router takes over from there. And so the React router is what specifies all of the different like URL routes within the app that have React parts to them. And so the course part of it is basically says, okay, the courses is the root path, and then there's sort of a specific path for whatever course page you're on. And then different tabs within that are all subroutes of this. So we have a timeline tab of a course page and a wizard tab of a course page, and some modals that sort of pop up over things. And so these are represented by this nested set of routes in the React router. And so whenever one of these pages gets loaded, React starts and renders whatever components are specified here to start building up the page. And so generally that happens by first it has a sort of top level empty app component, which like looks like this. This is the entire app component. And then whatever router specifies as the children that are relevant for that specific route, those are the components that starts to try to load. So for the course pages, these all load the main child component of the course page component. And so this is a complex component that basically determines the sort of high level things about what happens in the course page. And so whenever one of these renders, it'll be something like the course page will also have a child component of whatever tab it's on, which would be, for example, the main tab, the overview tab. And so it would start to render this overview component within the course component. And the first thing that this does when it routes, it doesn't have any data. It doesn't know what to display. And so it launches some server actions. And so these trigger some AJAX calls that go off to the server and hit some endpoints on Rails, hit some JSON endpoints. And once these resolve, the system like broadcasts a message throughout React that says, we just received data for this kind of thing. And the way that React works is that it's supposed to have one-way data flow. And so instead of that data coming right back to the place where this call started, it broadcasts it throughout the system. And all of the components that are set to listen for that message hear that message and act on it accordingly. And so typically that is a store will hear that. And so a store is how React keeps the state for the whole application. And so one of these stores, we use a framework called McFly, which is sort of one of the older generation of libraries for handling React state. And newer apps typically use something called Redux, which we may do eventually. But so you have a store, which I'll sort of get over to a store here. And in the store does something like responds to a message like, let's see, here's a store I think that will receive some messages. So this store listens for the message receive timeline, and then when it does some actions with that data. And then once it's done, this store will issue its own message. It'll issue the emit change message for the store. And so at this point, other things are subscribing to what this message got sent. So the component that started all this, if we return to this course overview component, it has a mix-in of one of these stores. And so whenever it receives that message, it says store did change. And so it runs this store did change and gets that data out of the store. So that's the sort of clumsy version of the one-way data flow of how React works. So it issues a command off to the server, and then once that resolves, that goes to a store. The store emits a signal, which triggers this component to fetch the data from the store, and then this whole component will re-render itself. And so that is sort of the order of how the app loads in the first place. And at this point, now that it has the data, instead of just rendering a spinner, now it's going to actually populate all of the details of what this course looks like. And so that's sort of the basis of the single page app experience for this, like for the course pages. So you can click from tab to tab, and it's not actually reloading the whole page. The React router is still basically keeping the same set of state and just calling new AJAX calls to fetch new data as it needs, and rendering whichever components that it needs. And so if it already has the data it needs in the store, then it may not need to like recall to the server to get the new data. And so it'll just sort of feel instantaneous for the user as they switch from place to place. So that's kind of the way that this app uses React. It has the Rails backend that provides just the JSON data, and then JavaScript is responsible for almost the entire user experience. So that's the course pages. We have a couple other React systems as well. So we have the training pages and an onboarding, which basically are like much smaller, and they work pretty much independently of the main course pages, but they're still represented in that React router. And they're sort of like a lot simpler to see where all the data is coming from and going to. So that's sort of the React part of the system. I guess I want to pause here and ask if there's sort of questions or anything that I can do to like help people along before I move on.
So the React backend, so you just pass JSON to it from the Rails, correct?
That's right. So there's a lot of JSON endpoints that are built with JBuilder views.
Okay.
And then I guess I sort of glossed over how the whole part works to begin with here, but I'll walk through it in a little better way right now. So back to this. So when this component mounts, it runs automatically because of the way React works. The first thing it does is fire off this component did mount. And so this says, okay, we're going to run this server actions fetch command. So that so we have a whole set of like actions files, including this server action, which is basically just a way to handle the AJAX calls. And so in this case, this says, okay, we're actually going to pass this to the API, make the certain call that corresponds to, and then when that resolves, it says, okay, respond with this action type. So like an action type like receive course clone or like receive wizard index or whatever data that you asked for, there's a corresponding action type, which is basically just a string. That's the content of the message that then gets broadcast. And so then you have stores that subscribe to these specific messages. And so every store is listening for all the messages that come across the system. And one of the stores knows how to respond to this specific message. And so when it does that, it'll take the data that came back from that AJAX call and process it. And so that's the sort of gist of like the way that the data works between the Rails backend and the JavaScript front end. Did that help, Hinesh?
Yeah, perfect. It's just the React looks a bit daunting when you look at it, but actually when you get into it, it's not that bad.
Yeah, that's it's definitely like a learning curve, and like a lot of different React apps set themselves up different ways, and so the particulars of like how that data flow works can vary from app to app. But the principle of like listening for the messages and then like re-rendering based on when the data has changed, and then in this particular case, understanding that you send a message off to the server and then you're expected to process that message when it resolves by handling it in a store and then pulling the data from that store in the component is sort of the key to like figuring out most of the particular cases in this app.
Okay, cool.
So I have a question regarding, so you said that you use React heavily in courses and somewhat less heavily in training and onboarding. Are those, and almost like you were describing different segmented React apps, are they actually just one app with one empty app that gets loaded up, or are they separate React apps with their own stores, etc.? And how does that all come together and interplay with each other, if so?
Sure. So that's a great question, and so the quick answer is that all of the ones that I just mentioned are one app, and the best way to visualize that is with the router. And so if we the router is kind of hidden away in like the utils directory here, but so the React router is sort of a special bit of React, and the way it works is you define this sort of nested set of paths. And so anytime that the sort of JavaScript sees a React root sort of element in the HTML, which is basically, if all you're using is React, that could just be like a single line of HTML is all you have, and that's just the React root that says, okay, JavaScript, mount the React here and start doing the React stuff. Then, so that's basically like what the main what the main JavaScript file does. Its job is to insert the React stuff wherever it sees the React root. And from there on, like this React router takes over. And so it tries to match the path. And so it has like the top level component here is component equals app. And so that means that for any route where the React has found some HTML to latch onto and start up, it's going to try to render the app component. And then within that app component, it's going to render whatever children components the rest of the sort of nested routes correspond to. And so it'll render if I'm on the root URL / onboarding, then it's going to render app, and within app, it's going to render the onboarding component. And then if I'm actually on onboarding / onboarding form, or onboarding form, then it's going to also render within onboarding a child of that onboarding form. And so the courses bit is sort of has deeper nesting, and the components are more complex. And all these components are sort of built to be rendered within the course component, whereas these other ones, like onboarding, sort of have fewer levels of nesting, and the components themselves work independently. And we could put them in a separate React app, but it is all one app, and it's all going through this top level app component, which is basically just the app component has a notifications component so that we can render notifications no matter which place you're at. And then all it does is hold the children. So its whole job is just to be the container. Did that clarify things a little bit?
Yeah, no, absolutely. Thank you.
Great. So is there any more like React related questions that you'd like me to go into before I move on? Okay. So that's sort of the React story of it. And the next sort of bunch of bits that I'm going to talk about are some of the other aspects of it, which maybe the easiest way will be to well, I'll stick with the code version of it. So we have like a landing page where you go if you're sort of at the root of the whole app. We have like an explore page where you can see all of the different courses that are happening. We have like aggregations of courses that are happening called campaigns. And we have like user profile pages, and we have a bunch of other miscellaneous pages, some of which are sort of admin oriented. And most of these, you can sort of get a sense for how many like different pages that we have, which is kind of a lot. If you look sort of over here, these are all of the controllers that we have. So it's a sizable number of controllers, and many of these are sort of individual pages or like sets of pages that are independent of the course pages themselves. Many of these controllers are for the different elements of JSON data that the course pages pull, but many others are just independent bits. And these are mostly pure Rails. And so you have something like the Explore page, which is just a very simple controller, and it sets up a presenter. And then the views are all just done in HAML to, where am I? Explore page. It just has a HAML template with rendering some partials. And so that's all done in sort of a very conventional Rails way. And there's little tiny bits of jQuery that add sorting and like little bits to the user experience. But large parts of the app are essentially pure Rails. Another thing that we have in the app is the survey system. And the surveys are done, where are we? So the surveys are done via rapid fire, which is a Rails engine. And so this is basically a whole nother Rails app that's designed to do surveys that we sort of grafted on to the dashboard. This is a sort of an interesting thing because it's basically a pure Rails system, but we added sort of a whole new user experience on top of that, using like a combination of things. So we monkey patched a bunch of features that we wanted to add that happened sort of during initialization, which that's sort of over in initializers. There's this very complex, you can sort of see over on the sidebar, the outline of the code, survey initializer file, which does all of the monkey patching that we do for this essentially whole other Rails application. And then on top of that, there's a separate JavaScript or set of JavaScripts that just handle the surveys. And so we have this whole surveys folder of JavaScripts that does things like takes the HTML output of this Rails engine and turns it from a whole page where you have every single survey question all in a row to something where you can go question by question. And once you answer one question, then it presents the next question, and also adds some of the features that we needed, like conditional questions, where we'll only show you one question if you answered a different question a certain way. So like follow-up questions, things like that. And so we have this big ball of jQuery, which handles that part of it. So if you're looking for like lots of great anti-patterns and things not to do, there's all kinds of fun to be had in the surveys part of this. It's sort of like multiple levels of bad practices and disaster conceptually. Like, we've done the best that we can with it, and there's a lot of good stuff buried in there. But this is a part of the system that's been very painful to work with. So there's that. The next thing that I wanted to mention in the overview is how we handle users and user accounts and sort of like identity and authentication. So when you're a user and you log in, we use OAuth with Wikipedia itself, because sort of the whole system is based around helping people do things on Wikipedia, and so we want to make sure that identities are matched between Wikipedia and our dashboard. So basically, we use an OmniAuth strategy to use OAuth and log into Wikipedia. That's how you log in the first place. And then we also get permission from you when you do that to use your account to actually make reciprocal actions on Wikipedia. And so we have there are a number of like pure Ruby classes that basically handle this, where we can take a user and make the calls off to OAuth, and then do things like, if you sign up for a course, then we use your account to make an edit on Wikipedia and change your user page to say, this user is in this course. And so that stuff is, so the various ways that we talk with like Wikipedia are encapsulated in a couple different classes in the lib folder. Some for sort of just talking to the Wikipedia API and getting information out of it, and some for talking with it through OAuth and putting information into Wikipedia, and then interacting with some other wikis as well. So there's sort of conventional API and sort of data pipelines that rely on this. And closely related to that is our data cycle. So the way that this app works is that it periodically pulls in all the activity that participating users and classes have done on Wikipedia, because its purpose is, among other purposes, to like highlight what this group of users is doing, so that people can help them and so that they can sort of feel proud of what they've done. And so that is organized primarily like through the this lib data cycles folder. And so the app works by having like two main update cycles: the constant update, which basically it tries to run as often as it's able, like one at a time, and then the daily update, which pulls in additional data that doesn't change continually, but like gets updated actually on Wikipedia at a slower rate. And so these two are basically like a whole series of steps that it does to pull in new users, check whether usernames changed on Wikipedia, pull in new revisions in articles, check how many page views those articles got on Wikipedia, and then do also sort of the caching that it takes so that you can have like all these stats that show on the course pages, like, you know, how many bytes got added by all of the revisions across all of these users. So we cache a lot of those things, and that happens as well at the time that we pull it in. We pull in new data, and then we cache a lot of that data on the models, on the course model, on the user model, and on some models that are sort of more specifically cache related. And so these issue off a whole bunch of routines that basically have different ways of talking with both the Wikipedia API and other sort of related APIs that are designed to provide metadata about Wikipedia. So like Plagiabot is a system that tries to identify plagiarism on Wikipedia. And so we say, okay, well, we want to find out if any of the edits that have been made recently by people using our system were plagiarism, so that we can have someone say, hey, this is not what you should be doing. You should fix that. So this data cycle sort of directory is where you can go to get the high level and like drill down from there to see all of the different things that happen with just the data management side, which is mostly like independent of the user interface and like what users are doing, but it's actually like one of the critical parts of the application. And then the last little bits that I wanted to get to are some of the sort of developer-facing bits. So we have a style guide, a living style guide, which I will show you actually now. Let me switch off, switch into another window so I can show you. So if you're running this locally, you'll find it if you just put in /style guide at the end of your URL. And actually, it's also live in production as well, but we just don't advertise it anywhere. But so this is a living style guide that will give you tools to design new features using sort of the same design building blocks that we have in place. So you can sort of see how tables are used and inspect like what the HTML and CSS and JavaScript are to sort of put some of these things together, and like tooltips and alerts and just all of the little building blocks that go into the whole system. So if you are doing new design work, this is something that you might find interesting and want to be aware of. And we also use this to sort of keep track of some of the things that could be improved on the design side that we haven't gotten to yet. And then the other bits are how we do testing. And so we have two different test folders. Oh, let me switch over back to here again. So we have the spec folder full of our spec tests of all sorts. We have our fun controller tests and our feature tests, which use Poltergeist to run like browser interaction tests, where a lot of the JavaScript heavy features sort of get tested. And then we have a lot of unit tests for the data handling parts of it. And overall, we have very good test coverage, at least in terms of line coverage for like the Ruby side of the application. So it's like actually it's almost 100% line coverage, which is obviously not perfect, but like working in Ruby, you can be fairly confident of the tests that if they're still passing, you probably didn't break anything critical. Or you almost certainly didn't break anything critical, and you probably didn't break anything at all. And then we have the test directory, which is for the JavaScript tests. And so the JavaScript tests are much more sort of patchwork, and in general, it's not trivial to sort of wrap your head around how to do like unit testing at a good level of granularity. But we use Mocha and some of the React testing tools to try to do some tests of individual components and individual bits of JavaScript. And so right now the nominal like line coverage is something around 50% of the JavaScript. And that's something that over the next couple months, I'm hoping to spend some time really improving on. All the JavaScript is done in like just pure JavaScript and JSX. And we migrated from using a lot of CoffeeScript to doing this. And now that we have it all in pure JavaScript and JSX, we have sort of a like testing pipeline that allows us to actually see the coverage from the original source. And so that is sort of the foundation that I'm going to use to try to improve our test coverage in JavaScript. And so the general practice is that I generally expect like good coverage of new Ruby work, and like I like but don't require tests for new JavaScript work. That's kind of the end of where I was going to go with it, and we're right about half an hour. This is a good time. I should have stopped for questions earlier, but now is as good a time as any for more questions.
Just a quick one.
Mm-hmm.
On the sprint board, which stories have been estimated, have you worked on?
On the sprint board, which stories have been estimated? Let me pull up the sprint board if I can here.
You've got 3 columns. You've got backlog, agile venture backlog, and estimated.
Sure. Estimated are the ones that have been like estimated by us. I try to do like whenever I triage new issues, I try to mark out ones that I think are going to be pretty easy for someone new. They're marked as newcomer friendly, but that's just sort of my informal first glance at it. And newcomer friendly probably means more that you don't need deep understanding of like the context of the whole app, and you don't need deep understanding of like the business logic to fix it, but not necessarily that it's a tiny task. But the way that I have been handling things is when new things come in and I think that they would be like good self-contained things that someone on Agile Ventures might work on, then I tag them with the Agile Ventures backlog instead of just the general backlog, which is kind of, it's very big, and a lot of the things sort of require a level of like familiarity with the whole project that they just don't seem like good fits. And so the Agile Ventures backlog is things that as a Agile Ventures group, we haven't estimated yet.
Okay.
So Sage, is Rails involved with rendering every single page, at least at the layout and footer level, or are there some pages that are rendered solely with React and no Rails components at all?
There's Rails involved on every page. So the like the top navigation is done in Rails, even for like a course page. If I just like show you so this part up here, which has the different tabs that are available and like the login, logout bit, that's pure Rails HTML stuff. The footer as well is Rails. And then on a course page like this, everything in between is the React.
So one of the reasons I asked is that on some pages, which are primarily driven by React, if I hit the page refresh button on the browser, it goes back a view or two to what I think was the last page primarily rendered by Rails. which is a bit disconcerting because I want to just load the page, reload the page I'm looking at, but it'll back me up.
Can you give an example of?
Well, the diff viewer, for instance, go into a.
Yes. Okay. So if you're the diff viewer, which I'll switch over to the production site so I can be sure that I can find some diffs quickly. So we have all the articles that this person worked on, and we're going to show the diffs. And so in this case, the diff viewer is done like as a modal that is like the URL hasn't changed. So the React router doesn't know anything about this. And so the URL here is still the same URL as just as this right here, this articles tab. And so if I refresh, I'll still be on the articles tab, but the diff viewer will not be there. I would have to click through to do that. And that's, I mean, it would be possible to like incorporate the router into that so that the diff viewer was actually like, the router was aware of it, and when you clicked, it would take you to the sort of like a diff viewer specific URL. But it's just not being done that way here.
Well, that wouldn't be surprising to the user because that actually looks like a modal. So I wouldn't be surprised if it goes away if I reload the page. But on my browser, the diff viewer doesn't look like a modal. Is that just I'm using a different resolution or something? It's not apparent to me that it's a modal at all when I'm looking at it on my browser. Yeah, it's like that. So it basically the modal size is bigger than the actual page I'm looking at. So maybe that's what's happening.
Yeah, and the design side of this is something that this modal, and then especially this other, the show current version one, is something that I'm actually going to be working with a designer, one of the designers who like did a lot of the original design work for this. And he's going to sort of do some both specific focus work on building out features for this view so that you can see which users did which bits. So it'll sort of highlight like the parts that were added by the users in this course. But then also he's going to do some general like user interaction, like review and refinement work. And how these modals work is something that I think there's some room for improvement on. But I'm not really sure at this point what the right design solution is for that. And especially for situations like the one that you initially encountered this in, and which we're seeing right here, where basically the modal is taking up essentially the entire screen and doesn't seem like a modal.
Exactly.
Because this is content that like you really do want a lot of room for, but you don't want the whole screen because like it's sort of, you know, it's a narrative type thing that you want it to look kind of like it does on Wikipedia, and like Wikipedia looks bad if you have it too wide anyway. But I'm not sure what the right way to go is.
Yeah, no, that makes sense. Now I understand what's going on.
Other questions? Comments?
Is this quite a how big of a support burden it is for supporting production? Is it, you mentioned you're working on a production issue now, but it'll take up a lot of your time, minimal time?
Spiking? I mean, I'm working on a like support issue now in terms of like a bug that like didn't realize was there. The other issue of like the crashing thing. Yeah, not that much. I would say it's been like very stable for like the last, you know, like 6 or 8 months.
Great.
I mean, we've, you know, over time, like a lot of work has been put into like, you know, specific performance things, and then like making it reliable enough that we don't have to constantly pay attention to it. But at this point, it's fairly like low maintenance on just like a sort of server and like admin perspective.
On the wiki page, on the project setup, you got, I think, 5 or 6 apps / servers you have to run, such as Zeus, Guard, Redis. Would you be able to explain what each one does? Because it's quite confusing sometimes.
Yeah, sure. So let me pull that up real quick. So after you've done the setup and you're ready to develop, and it has, let's see, how many steps are we up to? Well, 6, but 4 are sort of real steps here. So start Zeus. Zeus is just something that like helps like Rails start up really quickly. It sort of sees, it determines whether or not like sort of root level things in the Rails environment have changed or just individual files. And if it's just individual files, then it's able to basically like reload the Rails server very quickly after a change. At least that's my understanding of it. I don't actually use it myself on a regular basis, and so I'm not super familiar with it, but this is one of the things that like the developers who like started the app and like who I learned from basically, like they all use this and it seems like a fine idea, so I kept it in there. Redis is a key value store server that is like used for caching and other things. And in this case, the reason that we have it is because it's a requirement of Sidekick. Sidekick is a background job processor for Rails. It's kind of the most common solution for like initializing tasks from user interface or from like a cron job or whatever, and then having them run in their own threads in the background. And so it does that by sending off to Redis like all the details that it needs to run, which is basically like the name of the task and then like a couple small pieces of data such as record IDs, and then it can like run that in the background. And so Redis is a requirement for that, and we use Sidekick to like do some of the things that are slow that a user initiates, like talking to another server or sending an email or something like that, where we don't actually care what happens with that request in order to serve the user content. We're just doing it in response to what the user did. So we do that in background jobs. So that's why Redis is necessary. And then Guard. Guard is just sort of a development tool that you can use on top of or instead of the sort of standard like Rails development console. And it starts the Rails server, monitors all of the Rails files for changes, restarts the server whenever it needs to, and also watches. It's also a test runner for our spec. And so whenever like a model changes and you save that change, then it'll run the corresponding model's spec file. And so that's the purpose of Guard. And then Gulp is basically the corresponding server for the JavaScripts. So this project doesn't use the Rails pipeline. It instead uses just a bunch of like build steps that are all basically managed and like munged together with Gulp. And so when you're running Gulp, it monitors all of the CSS files and the JavaScript files for changes, and then it recompiles those whenever there's a change. And one of the steps that it does in most cases is it fingerprints the files. And so that way we know that we're serving the most up-to-date like file to the users in production, so that they're not caching old JavaScripts and getting like incorrect behavior after we've already fixed something. And then it also handles all of the like turning the JSX into pure JavaScript and doing the compilation of like the sort of ES6 to whatever the sort of things are that can run on sort of most browsers, and that's about it. So those are the main tools.
Excellent. Do you, for CSS, do you use Bootstrap, Foundation, or anything in particular?
This is the document to set up the system.
Vijaya, what was that?
This is the document to set up the system on my local machine.
Yes, setup.md in the docs, which is linked from the front page, is the document to set it up.
Okay.
And in terms of,
I have Windows-based operating system.
you have a what?
Windows operating system.
So we actually have some very new documentation on how to get a development environment set up in Windows, which was contributed by a Google Code-In student, a high school student, who was participating with Wikimedia Foundation in the last couple of weeks.
Okay.
So actually getting feedback on whether those instructions work for you would be fabulous.
Okay, can you put the links there or somewhere else in the wiki?
Yes.
Channel, I will go through that. Okay, thank you.
And to Hinesh's question, do we use Bootstrap or things like that? Those are like JavaScript, like layout frameworks. Is that correct?
CSS, yeah, JavaScript, CSS.
Oh, okay. So for the CSS, we use, we use stylus files, but I don't think that we use Bootstrap or other sort of specific that I'm aware of, like frameworks for it.
Okay.
I could be mistaken. We may use one of those things, and I just don't know about it.
No worries.
Okay. Others? Should we wrap this up? Hearing none, I want to thank everyone for coming, and I look forward to seeing you in the channels, and thank you very much.
Thank you. That was great.
That was a great review. Thank you.
Yeah.